My name is Lavleen Kala and this is the task 5.1p. So these are all of the files that I have made. We have the INO file, which is the sketch file. Then we have the CPP, which is the main file. Then is the header file. Then there's the timer.deacon.h and the timer.deacon.cpp file. So coming on to the main CPP file. So first we have this declaration. So basically here we are initializing the DHT22 sensor. After that we are creating an instance of the timer.deacon class, and then we are using a flag over here. So basically this is basically indicating whether the system should read the sensor data. After that we have LED state too low. So this is basically a boolean function which is keeping track of the LED state. And then current blink frequency is 0. So this is basically storing the current frequency at which the LED should blink. And then last sensor read time, this is basically used to track the last time the sensor's data was read. And after that we have the boolean function to determine whether the LED should be actively toggling or not. After that we have the first function, which is the setup hardware function. So basically here we are just initializing or introducing all of the hardware. So DHT begin is here initializing the DHT sensor. Here we are configuring the LED pin as output, and then we have the digital write LED pins. This is basically turning the LED off initially. Then we have this timer setup. This timer is configured to trigger an interrupt at a default blink frequency, and that frequency is 0.5 hertz. And then we are storing that in last sensor read time. After that we have another function, which is the read temperature function. So this is basically used to read the temperature from the DHT222 sensor and adjust the LED behavior. So what we're doing is we're taking the sensor's reading and storing it in humidity and temperature, and then we have this entire logic. So basically if our temperature is greater than 25 degrees Celsius, the LED should rapidly blink at 20 hertz, and if the temperature is less than 10 hertz, then it should slowly blink at 0.5 hertz, whereas if it is between 10 and 25, the LED should be turned off. After that we have the setup LED interrupt function over here. So this is basically configuring the hardware timer to adjust the blink frequency of the LED. And after that we have the toggle LED function. So this is basically toggling the LED on and off based on the LED toggling active flag. Then we have the ISR, which is the interrupt service routine, for which we are handling the timer interrupt to manage LED toggling and the sensor reading. So if 10 seconds have passed since the last sensor reading, the temperature is read and the LED behavior is adjusted accordingly. And the timer we are tracking using this millis over here, and we are comparing it against the last sensor read time to ensure that we have the 10-second interval. So this is my video demonstration. So I'll begin by uploading the code. And it says done uploading. So the LED isn't blinking as of right now, and I'll just go to the serial monitor. And it is not blinking because the temperature over here is 24 degrees Celsius. And it's less than 25. The temperature is between 10 and 25, which means that the LED will be turned off. Now I'll try and increase the temperature to make sure that the LED blinks at a faster pace. So I'll just use my hairdryer. And now the temperature has reached 58. So as you can see that the LED is blinking at a faster pace.